So pi over 12 is the same as 15 degrees. So this is saying what is the sine of 15 degrees. So we just have to figure out how we can get to 15 degrees. We can't add any angles to get to 15 degrees. So we have to use the sine difference formula or sine difference identity. So I want to do pi over 4 minus pi over 6 because I did pi over 3 minus pi over 4 first period. So I'm going to do, let's do 45 minus 30. So we're going to do sine of pi over 4 minus pi over 6. So go ahead and find this identity on your identity sheet. The sine difference identity on your purple sheet. And every place where the angle says alpha, I want you to put pi over 4 in this place. And every place where the angle says beta, we're going to use pi over 6. So it becomes the sine of pi over 4 times the cosine of pi over 6. See, I'm just inserting that angle. So my alpha angle is 45 and the beta angle I'm using is 30. And then it says in that identity to subtract the cosine of pi over 6 times the sine, the cosine of pi over 4 because alpha is pi over 4, so let's fix that. So it's the cosine of your alpha angle, which is your bigger angle, which is going to be pi over 4, times the sine of the smaller angle. All right, so go ahead, take your unit circle out and figure out these 4 numbers from your unit circle. So the sine of pi over 4 is root 2 over 2. And what's the cosine of pi over 6? Root 3 over 2. Minus the cosine of pi over 4 times the sine of pi over 6. We multiply. That gives us root 6 over 4 minus root 2 over 4, which can be written as a single fraction because we have a common denominator already. And this would be my final answer. If you have a calculator, if you type in the sine of 15 degrees, some calculators, like those yellow calculators, will actually give you that fraction. It'll say root 6 minus root 2 over 4. Okay, any questions about that? Now we're going to go to tangent. Tangent is a little bit more complicated because it It's just a problem, you know. We have to divide stuff to get to it. So, all right. So let's go ahead and take a look at our tangent identity. Yep. So that's why you have to show your work, and that's why we don't let you use calculators. Okay. So now let's go ahead and go to tangent. So these are your two tangent identities. This is your addition identity and your difference, your sum and your difference identity. So we're going to do, let's go ahead and find the tangent of 7 pi over 12. So go ahead and copy this down, and this is the identity. I just put it on the slide that we're going to use. So 7 pi over 12, we've found that angle quite a bit. And because I want us to practice with addition and subtraction, we're going to do addition. So to get to 7 pi over 12, who remembers the two angles that we add together to get to 7 pi over 12? Yeah, pi over 3 and pi over 4. Exactly. Good job. So I'm going to take the tangent of pi over 3 plus pi over 4. So my alpha angle is pi over 3 and my beta angle is pi over 4. So let's go ahead and write it out. So this identity says you take the tangent of alpha, so that would be the tangent of pi over 3, plus the tangent of pi over 4, divided by 1 minus the tangent of pi over 3 times the tangent of pi over 4. So part of the reason why tangent is a little bit more work is because we have to divide to get tangent. So we can't just look at the unit circle and know the tangent. In order to find tangent, we have to divide. So let's go ahead and do a little bit of work off to the side. Let's determine what the tangent of pi over 3 is equal to. So the tangent of pi over 3 equals the sine of pi over 3 divided by the cosine. So let's go to your unit circle. Take the sine of pi over 3 divided by the cosine of pi over 3. So we have to do the keep, change, flip. So we're going to have root 3 over 2 divided by 1/2. Go ahead and do copy, change, flip. To get your final answer. So I'll let you do that. So if you do that, you should get root 3. So who got root 3? All right. So now let's find the tangent of pi over 4. Tangent of pi over 4, well, that's pretty easy to get because we're going to take the sine of pi over 4 divided by the cosine of pi over 4. And we have root 2 over 2 divided by root 2 over 2. And anytime you divide two things that are the same, you get 1. So what I want you to do now is every place where it says tangent of pi over 3, I want you to write root 3. So this becomes a root 3, and this becomes a root 3. And then every place where it says tangent of pi over 4, well, then we're going to put a 1. So this becomes a 1, and this becomes a 1. So let's rewrite that. So this is going to equal root 3 plus 1 over 1 minus root 3 times 1. Okay. So we can't leave it that way. Does anyone remember going back to Algebra 2, why this is a problem? Maya? Cannot have a radical in your denominator. So how do I get rid of the radical in my denominator? That's the bonus question. Anybody remember how to do that?
Multiply by 1 except in a different form.
Okay, multiply it. What did you say?
The reciprocal.
Not the reciprocal.
Don't you multiply root 3 over root 3?
No. So who remembers the word conjugate? Spanish. Okay. It's actually a fancy word, but it's really not that fancy. It's derived from, you already know this because the difference of two squares, that's conjugates, like a plus b and a minus b. So what I'm going to do is multiply by the conjugate of 1 minus root 3, which means I just changed the sign to the opposite. So I have to multiply top and bottom by 1 plus root 3. That's how you eliminate a radical when it's a binomial. Okay, so let me go ahead and make myself some space. Hopefully we have all of that. So I'm going to make a box, one for the numerator and one for my denominator. So let's do the numerator first. I'll put an N for numerator. So this is what I'm multiplying in the numerator. I'm multiplying the square root of 3 plus 1 times 1 plus the square root of 3. So let's go ahead and fill in these 4 squares. So 1 times the square root of 3 is equal to the square root of 3. And then 1 times 1 is 1. And then this box I have the square root of 3 times the square root of 3. So does anyone know what that would be? What is the square root of 3 times the square root of 3? Just 3. Because it's root 9, and then that becomes a 3. Yep. And then this last box here, what would go in this last box? That's a root 3. Good job. So we're going to combine our like terms. So these are like terms because they have the same number underneath the square root, but we're adding the number in front. So this is kind of like adding 1x plus 1x. So 1 root 3 plus 1 root 3 is equal to 2 root 3. That's not equal to root 6. That's just 2. We have 2 root 3s. So in my numerator, I'm going to write it at the top, my final answer. So the top part of my numerator is 2 root 3. Because that's what I get when I add this direction. Now what do I get when I go this direction? What's 3 plus 1? 4. All right, so now let's do that again for our denominator. So I have 1 minus root 3 times 1 plus root 3. Go ahead and fill in your 4 squares again. So that's what you should have in your 4 squares. Oops, I messed up. One of those squares is wrong. Which square is wrong? The 3, yeah. What should it be? Yeah, that should be a negative 3. Okay. So the reason why, when you multiply 2 conjugates, these are always going to cancel, which is what we wanted to do. So when I add negative root 3 plus a positive root 3, they cancel out, which is what I wanted. So I eliminated my root in my denominator. And I have 1 minus 3, which is just going to be a negative 2. So this would be my final answer. Now, but I would be wrong if I didn't tell you, though, because, again, most of you are going off to somebody's college next year. Some of you are. You should know that there is a way to write this in a different way. So what would be the other way?
Negative root 3 minus 2.
Right? Negative root 3 minus 2. So what we did was I just divided these. So if I take these 2 and I divide it, I'm dividing by negative 2. So this becomes a negative root 3. And when I go this direction, I would have a minus 2. So this would be the best answer. I would take either. Any questions about how we arrived to that answer? Tangent, again, takes a little bit or maybe a lot more work. Let's be honest. It's not a little bit of work. It's a lot more work. Okay, so we practiced the tangent sum. Now let's practice tangent difference. So let's do our last question for the day. Go ahead and copy that down. Tangent of 15 degrees. Okay, so let's do the tangent of 60 minus 45. We could also do 45 minus 30. But I try to switch it up between first and second period, so I'm not doing the same questions the same way. But when you're doing your test or your homework, you just need to pick 2 angles that subtract to be 15. And it doesn't necessarily have to be in quadrant 1. You could pick any 2 angles. So but like I was saying, you could do 45 minus 30 also. So alpha is 60, beta is 45. So let's go ahead and fill it in. Every place where you see an alpha, we're going to put a 60. Every place where we see beta, we're going to write 45. So I have the tangent of 60 minus the tangent of 45. That's all over 1 plus tangent of 60 times tangent of 45. So we know tangent of 45 is already 1, so that's pretty easy. But we need to figure out tangent of 60. So go ahead, do your keep change flip, figure out tangent of 60 degrees. Remember, tangent is equal to sine over cosine. No, we didn't? Oh, okay, never mind. I'm just joking. Okay, so 60. So the sine of 60 is... So the sine of 60 degrees is root 3 over 2. And then we're going to divide that by the cosine, which is 1/2. Go ahead, do your keep change flip. And what do you get when you do keep change flip? Do we get root 3 or root 3 over 3? Just root 3. So root 3 is my tangent of 60. So I need that for this identity. The tangent of 60 is root 3, and the tangent of 45 is just 1. So let's go ahead and substitute that in. So wherever you see tangent of 60, we're going to put a root 3. And whenever you see tangent 45, we're going to put a 1. So that's going to give us root 3 minus 1 all over 1 plus root 3 times 1. So this is going to be very similar to what we had in our last example. So the tangent of 45 is positive because in quadrant 1, everything is positive. All right, so what am I multiplying by to get, so to eliminate the square root in my denominator, go ahead and see if you can finish it out. Multiply top and bottom by 1 minus root 3. Okay, so my final answer and my numerator, I'll write it in red. I'm going to have 2 root 3's. So 2 root 3. And this would be minus 4. In my denominator, my square roots cancel. And I'm left with just a negative 2. Now this can also be reduced and written as negative root 3 plus 2. Okay, just a reminder that you did have an e-learning assignment that is due. It's 50 points. I am going to update Skyward. I have a lot of homework to put into Skyward. In addition to that, Canvas assignment. Can everyone take out homework 11? Because we are finished a little early. And let's work on that now so that you'll have that and you can turn that in on Tuesday. So let's take out homework 11 so we can work on that now. It's only 6 questions.